like when you cube a number that's less than 1, it like gets smaller, right? So this one's going to be like
squished in
versus like a regular. So instead of getting a circle, you're going to get like a squished in circle. In fact, you could ask her it's pointy. You could do. We even did this in calculus. There was a worksheet called something like more.
Parametric curves.
More calculus. No, it was called something even more weird, like more implicit differentiation review. And page 1 is a big old asteroid, and you like did stuff with it. Anyway, good. We're also familiar with the asteroid. It has a geometric definition, which that's what Michio was up on the board, like trying to do as the bell's ringing, and he was like 90% correct, maybe higher. It is the shape formed as a circle. Roll of radius 1 rolls on the inside of a circle of radius 4, as seen in this.
Wait. Oh. Okay.
Yeah.
How do I zoom in?
How do you like super zoom in right now? Oh. Yo.
Oh, you probably can't see it because it's like
you can't see it because the light is like being bad.
Okay, good. 2 questions. What 2 questions which you're going to answer right now? Go.
Is this touch?
What is the area inside the asteroid, and what is the arc length of the asteroid? Set up the integrals and then do them by Wolfram. Go.
Are you?
So like just quadrants. And what else do we have?
We have 6 minutes.
One and then
Yeah, I feel like it's wrong.
Oh,
It should be about.
I do not know how to do this at all.
well, we would find the area of one of those quadrants.
I'm talking about the length.
Do you remember how we did that? That right there.
What?
Yeah, bro.
I get the like the root
Of one second or the same side. No, there. The asteroid is the area.
I know, like, I get it exactly. But like,
oh, it's the AP from Space Odyssey?
Oh yeah, I looked up to him.
The one that's the model of that's the one. You're the alien.
were you the ones?
Yes.
The whole day.
Can you see well?
500 IQ.
All right. Let the record show that students are dutifully working on this problem.
I don't know what that is.
Off camera. Good. So how do we find the area inside the asteroid?
I'm standing like right in
You are standing right in front of the camera. Good.
Iris, stop
It's going to be
standing
the sum of a whole bunch of like
You know what?
y dx's, yeah?
Iris, can you?
Wait, this is like not okay. What's going on?
What do you mean not okay? Good.
Everything is okay now.
Wait, is Narumi using the camera?
Nurmi is using the camera very well. He is.
Okay, good. Oh, also notice that since the curve is being traced out this way, because that's just like a fact, then dx is like negative. So I need to throw in a negative in there. So I'm going to do negative the integral from 0 to pi over 2, because that's up there, yeah? And I'm going to do 4 of those, because I'm only going to do in quadrant 1, of a whole bunch of things that all have to form y dx. And y is a sine cubed t, and dx is negative 3a sine t cosine squared t dt. So this looks just terrible. What I end up with is 12a integral from 0 to pi over 2. No, 12a squared. I'm going to back up this math. 12a squared sine to the 4th cosine squared. No, not squared yet because we're. Did I mess up? No, I don't think so.
No, you didn't. You just wrote it down.
No, but because it's y dx.
Yeah.
Y dx. So I think I did it right.
All right.
Okay, now this integral is particularly torturous. This one that I just mentioned, or this one that I just wrote on the board. So can we just not do it?
Yeah.
Yeah, good. You want me to just tell you what the answer is?
Yeah.
Good. It's I lost it. It's pi over 32.
Oh, okay.
No, it's going to take you like 20 minutes of work to get there. But it's like pi over 32. And therefore the answer to this is 12a squared pi over 32. What does that turn out to be?
You should move to the other side.
Or 3/8.
That's
So
interesting.
pi a squared times 3/8. Oh, that's actually pretty cool. What that says is something which seems actually quite reasonable. That the area inside an asteroid is 3/8 of the area of the circle that is like going around the outside of that asteroid. Cool?
Yeah.
Okay, and then the last thing is, what is the arc length of the asteroid? How do we do that one? We're going to take the integral from 0 to pi over 2 times 4
Nice.
of the square root of like dx squared and like dy squared. And if you sub in dx and you sub in dy, you get a big old integral. You want to know the answer?
Yeah.
It is 6a.
Really?
A. And notice, no, I guess it's like, does that make sense? Yes, it does. And by the way, what is the arc length of the circle? If this is like the point A comma 0, right? What is the arc length of this corresponding blue circle? 2 pi A, right?
Yeah.
Or 2, pi, A, whatever she said, yeah. So this is 2a pi. That's not, we usually say, what you usually say 2 pi A. Yeah. I don't know why I'm being weird. 2 pi A. In other words, and pi is like 3.14. So the circumference of a circle is like 6.28 times the radius. So it's a tiny bit more the length of this asteroid than the length of that same circle of the same size.
That's pretty whack.
Woo! All right, everyone, have a nice summer. Woo! I will see you all later. Good. Woo!